Alright, hello everyone. So in this video I'm gonna solve lots of medium level integration by substitution problems, specifically the problems in exercise 5 I guess in the note. But I'm not gonna solve every problem, but I'm gonna solve majority of the problems. Now when I solve these, I will explain common mistakes that you do that I didn't get to explain in previous videos. So I will make sure to put time stamps in my description box below so that you can right away go to those common mistakes and learn them. The ideal way to learn is to pause the video and try to do the problem by yourself. If you get it right, perfect. If you get it wrong, you can watch and learn how to do. Alright, so I will solve lots of problems here, okay? Let's start with this one, second question, because right away I can pinpoint a common mistake. Now here's the question for you. What is the substitute? What will be your u? Well, someone might think it's x to the 4. Absolutely yes, because it's an inside function. You might think it as the inside part of this expression, what you have in the denominator. Well, it is correct, okay, and the derivative of x to the 4 is a 4x cube, okay, so you might see x cube is somewhere else in the integral, so okay, so x to the 4 is the inside function. It should be our substitute. But really we can make this problem even easier if we decide our inside function or substitute to be x to the 4 minus 5. If we count that minus 5 also. It's not going to matter a lot here in this problem, but there are problems that it's going to matter. Let me show you a one. Let's say x times square root of x square minus 1. Here, if you just choose your u to be x square because it's inside function, and yes, it's inside a function sort of a x square, well, it's not going to be enough. You have to count that negative one. Then you can replace this whole chunk here by u, right? That's the idea. Now here, if you just choose x to the 4, still the answer is going to be right, correct, but you're just substituting u to the part of this function, right? So but instead if you choose x to the 4 minus 5, you can replace the whole term by u, right? So that makes our life easy, I should say. Sometimes if you do not choose that whole term, it's going to give you wrong answers, so you're going to stuck for hours. So remember that. Now the second mistake, or it's not a mistake, but a confusion or hesitant that you might have is, okay, my inside function is x to the 4 minus 5 and its derivative is 4x cube. Well, we don't really care about 4, but we do care about x cube being somewhere else on the integral. But you would expect it to be like the most natural thing that you would expect is x cube to be next to x to the 4 minus 5. Like you would be very comfortable if you see it like this. Oh, the derivative is next to my inside function, so yes, we can use integration by substitution here in this problem, but I am not sure because it's in the numerator. Do we care? Well, let's move on and try to solve the problem. Here's the thing. Don't get really confused or afraid of that x cube being in the numerator and my inside function is being on the denominator, my substitute being on the denominator. Don't worry about that, okay? The idea is derivative should be somewhere else in the integral, okay? At least for these easy type of problems. When you grow in confidence and experience, it will automatically come to you. Alright, so now what we do is we go ahead and find du over dx. Let's solve the problem without talking too much. So derivative of u is 4x cube, right? Now, well, let's find what is dx, right? Dx is du over 4x cube. Always remember, integration by substitution have two replacements to do, right? What are those replacements? Now we replace x to the 4 minus 5 by u. Let x cube be there. Dx is du over 4x cube. So that let this x cube be taken care by this other part, okay? So you can see x cube cancel out. See, x cube being on the numerator perfectly worked for us, right? So don't get worried, okay? Don't get worried about the position of your functions. Now here this seems to be like 1 over 4u, right? Don't forget that 4, 1/4. So let's take that 1/4 out of the integral. So you're integrating 1 over u with respect to u. So this is 1 over 4 natural log u plus c. Okay, absolute value of u. Now 1 over 4 natural log u is, what is our u? X to the 4 minus 5 plus c. Alright, so this is the solution for this integral. Okay. Okay, so let's solve another problem. The problem that now I'm gonna solve is another easy one. Then let's do another easy one and then go to a really tricky problem. So here this is an easy one. Alright, so what is u? Here I don't think you will have a problem with choosing u. U is actually x square, right? The inside function. Here inside sign you have x square, and on a side we can say its derivative is 2x. We have at least x, I'm sorry, we don't care about two constant multiples. Okay, so let's formally take the du over dx, which is 2x. Dx is du over 2x. So let's replace both. X sine u, dx is du over 2x. Now see what I'm doing. I always want to see this cancellation by myself. Okay, most of the integration by substitution problems you will be able to cancel terms like that. Okay, the remaining term after you substitute u by the derivative, this derivative replacement. So you want to see that by yourself, because it's a helpful skill. This is a helpful step that you want to write out explicitly when you're doing homework or when you're doing an exam, because it's going to help you a lot. When we move on through these integration lessons later, when we see harder problems, you will realize why. Okay, so then sine u over 2 here. So if you integrate sine u, don't forget you get negative cosine u. Do negative I negative plus c. So that's in our basic integration review playlist. So if in case if you have missed that, click on the link above to go and watch that. Okay, do negative I negative story. So negative cosine u is x square over 2 plus c. So this is the answer for the integral that I shown above. Alright, so let's solve our problem. Now I'm going to solve a tricky one, a real tricky one. Okay, let's say we want to integrate sine natural log x 1 over x. Okay, so this is actually the easy version of the tricky one, but anyway, let's do this one. I will then do a bonus one for you. Okay, what is the inside function? So clearly it's visible that there's an inside function, and we are almost naturally say that u is natural log x. Alright, so derivative here is, derivative of natural log is 1 over x, which we can see somewhere else in the integral, right? Or we didn't do the confirmation step. So derivative of natural log x is 1 over x. So actually it is 1 over x that you have, right? Don't think that this is just x. It's actually 1 over x. So derivative is still there. So when you swap these, now here for instance, be careful. Be really careful when you make dx subject, because here dx is x du, right? This x becomes to the numerator when we take it to the left hand side. Dx comes to the numerator when we take it to the right hand side. So it's actually, in previous problems we had dx is equal to du over something, but here we have dx is equal to x times du. So be very, very careful with those steps, because if you mess up here, if you have write this like dx is equal to du over x, oh, you're gonna get the whole problem wrong, right? Remaining whole problem. Okay, at least you're gonna stuck a lot. Okay, so let's replace. So this is sine u. Okay, that is why you need to write this x, and you need to write this replace of dx term explicitly, because now you can cancel this as you can see it cancel out, and you know that what you're doing is right, rather than doing this in your head. This is perfectly safe. So integral of sine u is negative cosine u plus arbitrary constant c, and u is natural log x. So right, so this is the solution. All right, now you might say, well, you did this easy problem, this was not tricky at all. Well, let me show you the tricky version of this one, of the same thing. I'm not going to solve the full problem, but here's a challenge. I am going to change this problem sine natural log 3x, okay, over x dx. So now first of all, let's get this clear. What is u? Is it 3x or is it natural log 3x? Now that's not the tricky part, by the way. It's natural log 3x, right? Don't choose 3x to be inside function because you want its derivative to be somewhere else in the integral. 3x derivative is just 3. Okay, well, we don't care about the constants, but if you choose u to be 3x, you're not gonna get away this term. And even though when you substitute, you get sine ln u, that's complicated even more, right? Still you have that sine natural log inside sign. So your what should be your inside function? So think about them. Inside function is natural log 3x. So choose that correctly. But that's not the tricky part I was mentioning before. What is derivative of du over dx? Now tell me what's the derivative. That's the challenge. Is it 1 over 3x? No, what I'm gonna say is it's 1 over x. Do you see that? This is a tricky one if you have forgotten differentiation rules. Because yes, if you differentiate natural log 3x, it's 1 over 3x times, now you have to differentiate 3x also, chain rule, derivative of 3x is 3 cancel out. So still the derivative of natural log 3x is 1 over x. That's super important. Okay, so don't miss out that point. Rest of the problem is very similar to what we just did before. Okay, so now I'm gonna solve another tricky one, not tricky one, but a little bit harder one. Let's make problems a little bit harder when we move on. Actually, these problems are not hard. Okay, what is your u? Again, my choice for u will be, is in negative 6x squared. No, don't just take negative 6x squared. Take 1 minus 6x squared. Take the full term, because when you do that, you know what you're going to replace is, you're going to replace this whole term by u. Not just if you just choose 6x squared, you're going to end up with 1 minus u. Even harder, right? So just replace this whole thing by u. Easier, right? But well, before that we need the confirmation. So what is the derivative of u? Well, derivative of 1 is 0. Derivative of this part is negative 12x. Do we have negative 12x somewhere else in the integral? Absolutely yes. Forget about negative 12. We at least have x. So yes, we can use integration by substitution. So du over dx is actual derivative is negative 12x. This means dx is du over negative 12x. So be careful with this conversion. Again, I'm saying. Now let's replace. So this is x over here. This is square root of u. See the advantage of picking the whole term to be u. Dx is du over negative 12x. Now I would like to see this cancellation. X goes off. Then what we have is, let's take this negative 12 outside the integral. So it's negative 1 over 12. Still that 12 is in the denominator. So when you're taking it out, it's still on the denominator. So what you are taking out of the integral is negative 1 over 12. So it's 1 over square root of u du. Now how do you rewrite this so that we can integrate easily? We can write 1 over square root of u as u to the half. Square root is u to the half. Well, we can take that u to the half to the numerator. We switch the sign of half to be negative. Power rules. Now if we integrate u to the negative half plus 1, divide by negative half plus 1 plus arbitrary constant c. Okay, so let's see what we get. Negative half. U to the negative half plus 1 is half, right? Divide by half. Now this division by half, we can write it as multiplication of reciprocal of half, which is something that we practice in basic integration review series, right before this integration by substitution series. So if you take the reciprocal of half, it's 2. So half, negative half multiplied by 2, u to the half plus c. 2 cancel out, so the answer, let's write it here. Why am I not using this much space that I have left here? Okay, so it's a bad habit of me. I'm terrible at managing space. So so this is negative u half. negative u half plus c. So what is u? What is u really? U is 1 minus 6x square. So square root, not square root, 1 minus 6x square half plus c. So in fact it is, yes, square root 1 minus 6x square plus c. Half power means square root. Alright, so this is the solution when you solve that problem. Actually it was problem 7 in the exercise. Let's do one more problem before we finish up this video, otherwise this video is going to be too long. I'm going to do a part 2 of medium level integration by substitution problems. Okay, now let me do a problem in this video where it's a little bit you're gonna hesitate with using integration by substitution. Okay, we are going to grow up in integration by substitution. In next video we're going to do really good problems. Okay, all right, so here what is u? You can easily guess u, and your guess is correct. So u is 3x minus 1. It is inside the square root, so inside function is 3x minus 1. What is its derivative? Derivative of 3x minus 1 is 3, right? Well, you might say, okay, do we have 3 somewhere else in the integral? We don't, right? But the idea here is, now you should be able to see this through. 3 is a constant, right? It doesn't matter. And I mean, the reason that we use the derivative of this u is to cancel out the other terms in the integral, other troubling terms. So for example, in this problem we use u to cancel out the x, derivative of u to cancel out x, right? Because we cannot replace it by u in an easy way. So here we don't have those kind of troubling terms except 3s minus 1. Everything else is a constant, are constants, right? So okay, so let's give it a try. Du over dx is actually 3. So dx is actually du over 3. Yes, right, I was just double checking my work. Okay, I don't want to get this one wrong. Okay, so yes, let's replace. So this is square root of u, dx is du over 3. It doesn't harm, it doesn't cancel anything, but it doesn't harm us too. So this is actually integral of 1 over 3 square root of u du. So let's take that 3 out. So it's 1 over 3, 1 over square root of u du. Okay, so we can write this as, now as we saw in the previous problem, 1 over square root of u is u to the negative half. So I did that really quick. Okay, so 1 over 3, if you integrate u to the negative half, it's u to the negative half plus 1 over negative half plus 1 plus arbitrary constant c. So let's write the answer here. 1 over 3, u to the negative half plus 1 is half, dividing by half, here it's half, negative half plus 1 is half, dividing by half is same as multiplying by reciprocal of half, which is 2 plus c. So this is actually 2 over 3, u, if I remember correct, 3x minus 1, so 3x minus 1 half plus c. You can even leave your answer in this form. Alright, so that's the answer. Okay, so then what I'm going to do is I'm going to see you in the next video if you want to see little bit of harder integration by substitution problems. Boy, they are really good problems. So definitely you should check the next video, which you can find in this link that appears in this video. Okay, I'll catch you there. Bye bye.